Okay, so I will repeat in the topic which we have started in the last session. Okay, so in the last session we have seen the resources folder, and we have find out the ESP32 development kit do it.fzpz file. Okay, you have to right click on it and you have to download this file. Okay, when you download this file will be downloaded into your download folder. Okay, so all of you perform this operation right now. All of you perform this operation. Those who are left with this part, they can complete the download part right now. So everyone, are you able to download this file? I am sharing this particular link with you in your chat. Okay, you can use this link directly and you can download this file right now. Okay, have you downloaded? Okay, so after downloading, you have to start your fritzing. Okay, so this is the fritzing software. You have to double click on this icon, application file, and you will see the dashboard like this. You have to start for the new project. Okay, and you have to open this new project. It is loading right now, and you can see the window, and you can click the parts right here, and you can use this import option and click on the download folder where you have downloaded the fjet file, and select that file right now, ESP32 development kit do it.fzpz file, and open it. Okay, when you click open, this part will be available in your part list. So generally, Praveen, this ESP is a microcontroller. Okay, we are using this microcontroller to control the hardware devices. As you have seen, there are different components. Okay, those components are used to perform different operations. Like there is a microprocessor, there is microcontroller. So these microprocessor and microcontroller will control the appliances. You have seen there is a laptop with you right now. Okay, in that laptop you are using i7, i3, i5, any type of processor. So that processor control all your hardwares. Like there is some volume control device, there is some yes, you have Ryzen 7, so that will control different hardwares like floppy drive. There is a CD drive over there. There is a volume control. There is a display control, like you have to increase the brightness, you have to decrease the brightness. There are different keys on the keyboard. So all these operation to be controlled by your central processor. Okay. So same thing this ESP32 module will perform in our case. This is a microcontroller. So major difference between microprocessor and microcontroller is that microprocessor is used for general purpose. We can perform multiple tasks over the microprocessor. Whereas in microcontroller, we can perform one task at a time. Okay, so are you able to understand what is ESP32 module, why we are using this ESP32 module? Quickly give your response. Okay, Praveen, understood. Now come to the next part. In the last session we have seen how we have to install this ESP32 module. Okay, So you have understood this. For completion of this software part and hardware part, we have to use the demonstration. Okay, so I am using the existing file. So there are different programs which are already saved in your LMS systems. Okay, so you can see there is a resource link and there is a software or experiment codes links right here. You have to open this link. Okay, experiment codes. Okay, click on this link and you will find this T1 intro folder. You have to right click on it and you have to download it. So quickly download this file. All of you, I am sharing this particular drive link with you, and you can directly download this T1 underscore intro file. Quickly perform this task right now. Are you able to download this file? Quickly give your response in chat. Yes, sir. Okay, so this file is downloaded and you have to extract it, and this file look like this. This folder is present right here, t1 underscore intro. You will find there are two files right here. One is used for the Arduino and another one is used for your fritzing. Okay, so we will use this existing file and we will demonstrate it right now. Okay. So you have to click on the file and you have to click on the open, and then you have to select your download folder, and in that download folder I have used this t1 underscore intro folder, and I have to select the current underscore state.fzz file and open it. So quickly perform this operation. Are you able to perform this operation? It is taking some time to load your circuit, and after loading our circuit look like this. Okay. So this is the complete circuit information which is available with you right now, and we are not using these components right now. For the demonstration purpose, I am explaining this. Okay, how you can use these components. So you can see right here. So this is the main dashboard where you can see all the components. Okay, and you will find these components are available on the right hand side. Okay, so I'm closing all these bars right now to demonstrate you how this circuit looks like. You can increase the zoom level by scroll up this mouse. When you scroll down your mouse, you will see the minimum view of your circuit. Okay, you can increase the zoom level by scrolling the mouse, and scroll when you scroll down your mouse, you will see the minimum size of your this particular circuit. Okay, for the demonstration purpose, we are not using these components. We are just explaining all these components right now. So this is your ultrasonic sensor. When you scroll your mouse over each component, it will display the name of that component. So Pranay is asking question in G1 intro folder on Google Drive, there are two sub-files. Yes, there are two sub-files. FZZ file is used for fritzing, and that Arduino file is used for Arduino. Okay, so this FZZ.fzz file is to be used for fritzing. Okay, so all these components to be connected into the board. Okay, so those who have already downloaded this file, they can use this file. I will just demonstrate all these components. So for the demonstration purpose, we need only the ESP module. Okay, we need only the ESP module, and we need to connect our LED to it. Okay, so remove the other parts. Those parts are not required for the demonstration purpose. Okay, so this is the second way. In this second way, you can perform the experiment. Okay, so you can remove the other part which are not required for our experiment, and you place those components which is required for the main experiment. Okay, So we are not using right now these components. Okay. So you have to delete all these parts. Okay. So this is the first part of your experiment in which we will demonstrate how this LED is going to be playing. Okay. So this is the main part right here. You have connected the D2 number pin. Okay. This is the D2 pin, which is connected to the register. Then this particular anode is connected to the LED and the resistor and the D2 pin, and then cathode is connected to the ground. Okay, this will complete your circuit. You have to power up this particular board, so that's why you have connected positive supply to this number pin, okay, D22, and negative connection is to be applied to this pin. Okay, so in this manner you have to connect your board, and you have to perform the experiment, okay, in fritzing. So just show you, this fritzing is used only for the demonstration purpose on how you can connect your board to the components. Okay, then you can also design the PCB layout when you want to design your circuit. Okay, so this first experiment is the hands-on session. We will not perform big experiments right here. You have to go through each component and you have to find out each component. You have to place these components and you have to take the snapshot and paste in the worksheet. That's all. Okay, this is the hands-on session. Okay, so I'm not going to save this, and I'm closing this application right now. And next part we will demonstrate you. mm, next next part is for the Arduino. Okay, so how you can use the Arduino. I am going to use your college PC right now. Okay, so I will use any of this link right now. So I'm using this PC number 7 link. Okay, I will copy this address right now. No one will copy this Zoom link right now. I am going to demonstrate you how this program is to be work in your Zoom link. Okay, so quickly take a look right here. I am copying this PC number 7 link. I am pasting right here. Okay, and when I am pasting this link in URL, you will see it will show me that this meeting will open in new file. So I will open this Zoom meeting right now. Okay, and this particular Zoom will redirect me to the college PC. So this college PC window is shown in my screen. Okay. Now you have to access this college PC, but right now you are not able to access this file. Okay. So what I will do, I will use this view option. I will use this view option, and I will ask for remote control access. So when I request for remote control, a message will appear in college lab PC, and our lab instructor will give us permission to start the meeting. Okay. So right now, I have. Wait for a minute. Okay, sir, रहने दो. Are you able to see the screen right now? Quickly give your response in chat. Are you able to see the screen? Okay. So this lab PC access is available with me. I can click on any of the icon right now, and I will double click on the Arduino file. Okay. You can see right here. I can double click on this file, Arduino file, and this Arduino is opening in my college lab. Okay, and this is the programming module. Okay, and you have to program this Arduino. Okay, so how you can program? You have to use the LED pin number 2. Okay, so that LED pin number 2 should be used for the programming. Okay, so this is the demonstration part. Okay, how you can use the college lab PC. I will show this program into my laptop. Okay, so quickly give you a response. Are you able to understand how you can start your Arduino? And you have to program right here. You have to program in this college lab PC. So two students will perform the experiment in college lab PC on Arduino, and two students will perform the experiment in FreeSync. Okay, so this is the main part which we have to perform right in the college PC. So we are able to see your screen. So what you are performing in your college lab PC, we can see all these information. Okay, so this is the circuit diagram. In FreeSync, you have to prepare. You have to connect this D2 number pin to the LED, and you have to connect the ground pin to this ESP32 module. You have to connect one capacitor to this point. Take the snapshot of this. Okay, and you have to connect this pin to the ground. Okay, this is the power supply module you have to connect. Okay, and this circuit is to be completed on your FreeSync. Okay, now come to the Arduino part, which will explain right now. So this is the start menu. You have to select for the Arduino. Okay, so this Arduino icon is appearing right now. Click on it. Okay, so I'm sharing the code with you in your chat. Okay, so that you can write this code immediately in your screen, in your college PC, and perform the same experiment. Okay, so this is the demonstration part. Okay, so you can see it. Now understand this program from this PC. So in first line, we are defining the LED2. So why we are defining this LED2? Because we are using this LED2 right here. So it is connected to pin number 2. Okay, as I have told you, this pin number 2 is to be used to connect the LED. So that's why we are defining this LED pin number 2. Now we are using the setup function. In this setup function, we are defining the pin mod. Okay, so this pin mod is defined as output. Okay, so you can see right here we have defined the pin mod for the LED as a output. So this LED will show you the output on pin number 2. Okay, now we are defining the loop function. So what this loop function will do, it will perform the continuous operation. Okay, infinite time this loop will run. Okay, until you stop the program, this program is going to be executing. So this digital write pin is used, this function, particular function is used right here to make the LED at a high position. Then we put some delay, and then again we place this LED to the low position. Then again we place a delay of 5000. Okay, so to execute this program, first of all you have to use the compile option. So this is the compile option. It will check for error. So when you have written your code, this code is written in high level language. It is written in C language. Okay, embedded C programming is used for writing this program. So this computer does not know this human readable language. It convert the human readable language into hexadecimal codes. Okay, and those hexadecimal codes are present in the library of this Arduino. It will check all these codes. If everything is fine, then it will give you OK message. if there is something missing or there is some spelling mistake in these commands, or then it will display you errors that at such so and so line there is some error, you need to rectify your error. So right now this program is executed, and you can see right here this sketch uses this type of memory, and it store maximum space this type, and it is executing properly. There is no error right now. Okay, now you have to upload this file. Initially you have to select your board. Okay, so when you select your, how you can select your board, so there is a tool option right here, and there is a board option. So in this board you have to select the ESP32 Arduino, and you have to select the Arduino do it. It is already selected in my PC, but it is better to check it before uploading the program. So this do it ESP32 development board should be used for installing your program. Okay, so this option is used for uploading the program. You click on this option. Okay, so our program is going to upload into the hardware. As you can see, the process bar is going on, and you can see this program is uploading in our system, and 100% it is uploaded right now. And I will share my screen, this camera with you, and you can see the LED blinking. Okay, so this is the LED blinking. uh, are you able to see this camera with me? As you can see right here, we have placed the LED, and right now LED blinking is changed. Okay, so we have placed 500 millisecond for the LED blinking. Okay, so this is. Are you able to see it quickly? Give your response. LED blinking is changed. Okay, so we again change this blinking speed. Okay, so let's change the program. Okay, I'm sharing the screen with you. This is the screen. Okay, so this is the program. Okay, I'm changing the uh, delay time to 100 millisecond. I'm changing the delay time to 100 millisecond, and I am uploading this program. I'm uploading this program, and let's see this into the camera. It is uploading, and okay, it is uploading. Okay, see the LED blinking. So the LED blinking is fast right now. Are you able to see it? Quickly give your response in chat. Yes. So in this manner, you have to perform your experiment. So can we start your breakout group right now? It is 100 millisecond. Yes, it is blinking for 100 millisecond. Okay. Can we start your breakout group so that you can perform the experiment? Quickly give your response in chat. Okay, so I am starting your breakout group right now. Okay, so there is a total 9 group right now. So I am going to divide you into 9 group. You have the permission to switch in between the groups. Okay, so when you switch in between the group, make sure that only 4 students should be present in one group. Okay, no more than 4 students. And you have to perform all these experiment in this group.